All right, class. Today we're going to start discussing areas of polygons as well as their perimeters, and we'll also be discussing some key terms such as apophthegms. But before we do that, we need to discuss some basic algebraic principles, and so let's do that first. On the left-hand side of the screen here, I have it listed as radical rules, right? So when I have here a simple adding of common like terms, for example, 1a plus 2a is going to give me 3a. Why do I mention that? Well, because eventually you might be asked to add um, square roots. So for example, here I have 2 times the square root of 3 plus 4 times the square root of 3. And that's equal to 6 times the square root of 3, because these are like terms. I don't want you to think that just, yeah, you can add 2 and 4, and you can automatically add the square root of 3 plus the square root of 3, and you might, by mistake, put here the square root of 6. No, what we're doing here is we're adding like terms. If you look here, though, I have 2 times the square root of 3 plus 4 times the square root of 3, and I can't add those because they're not like terms. The square roots are not like terms. They are here, so I can add them, but they're not here. Some other rules that you might remember from Algebra 1 is that you can multiply square roots. For example, the square root of 3 times the square root of 3 is the square root of 9. But you know that the square root of 9 is a perfect square, so that's equal to 3. Over here, I have the square root of 3 times the square root of 15. The square root of 3 times the square root of 5, which is equal to the square root of 15. The square root of 15 is not a perfect square, so we leave it like this. And of course, we have a scenario where we are multiplying two square roots. For example, 2 times the square root of 3 times 3 times the square root of 5. Well, 2 times 3 is 6, and the square root of 3 times the square root of 5 is the square root of 15. So what we have is 6 times the square root of 15. 6 is not a square root, so there's not much we can do there. Let's expand on this a little bit, though. Let's say, for example, well, we'll see more problems like this in our work today, okay? Let's move on. So why is it important to know how to do these things? Well, because there's going to be times where you have to use the Pythagorean Theorem. So let's review that a little bit as well. Here I have a right triangle, and I have two legs, and here I'm missing this side here. And if you remember, the hypotenuse is always the c. What does that mean? Well, remember that the Pythagorean theorem is a squared plus b squared is equal to c squared, right? So the hypotenuse, which by the way is across from the right angle, it's always the c in your equation, okay? So here we have a squared plus b squared is equal to c squared. So these both can be a and b, or b and a, doesn't matter, but this side here has to be c. So let's take a look here. So it's going to be 3 squared plus 7 squared is equal to c squared. 3 squared is 9, 7 squared is 49, equal to c squared. When I add these two, I get 58. 58 is equal to c squared, but I'm not looking for c squared, am I? I'm looking for just what? I'm looking for just c, right? So I take the square root of both sides. The square root of c squared is c, and the square root of 58 comes out to be 7.61. So the length of this side of the triangle is 7.61. In this instance here, again, I have a right triangle, except in this case, what are they giving me? They're giving me one leg, and they're giving me the actual hypotenuse. So remember, these two sides here are a and b. Doesn't matter which is a, which is b, but this side here has to always be what? Has to be c. The hypotenuse, the side across from the right angle, is always going to be c. That is non-negotiable. So I said this is a, and I'm going to make this b here. So here's my Pythagorean theorem. A squared plus b squared is equal to c squared. My a is going to be 4 squared. My b, which I don't know, is b squared. And the hypotenuse, which is always c, is going to be 6 squared. So 16 plus b squared is equal to 36. I'm trying to solve for b. I'm going to subtract 16 from both sides. The b squared comes down. 36 minus 16 is 20. I don't want b squared, though. I want b. So, of course, what do? I'm taking the square root, right, of both sides. The square root of b squared is b, and the square root of 20 comes out to be 4.47. So this third side here of the triangle, this leg of the triangle here is 4.47, okay? Now again, how do we tie these two concepts together? The radical rules on the left and the Pythagorean theorem on the right. How do we tie them in, and why do we tie them in? Well, let's take a look at an example here. Here again, on the left-hand side, this first problem here, I have a right triangle, and one leg is 2, and one leg is 2 times the square root of 2. But now I have to find the hypotenuse, right, which is c. Well, I'm going to have to use my Pythagorean theorem, except that now my side here isn't just a regular number, it's 2 times the square root of 2. And some of you might be a little bit confused on how to do that. So let's go through this step by step. And eventually you might find some shortcuts that work for you. And if you want to make a shortcut, that's fine. But let's take it step by step. So this is going to be my A. This is my B, which, by the way, we always said it doesn't matter. This down here could be A and this could be B. But the hypotenuse is always what? C. So I'm going to make this A and this B. So it's going to be 3, here's my Pythagorean theorem. So it's going to be 3 squared plus 2 times the square root of 2 squared is equal to c squared, okay? 3 squared we know is 9, but now we have 2 times the square root of 2 squared, right? Remember that when we square something, what does that mean? That means that we multiply it by itself 2 times, right? So I'll notice here I'm putting it 2 times so that I know I'm multiplying it 2 times, so I don't forget, okay? So I got 9, and I'm multiplying this, I'm squaring it, right? And that's equal to c squared. So my 9 comes down again. Now here I have, watch, 2 times 2 gives me this 4 in blue here. And the square root of 2 times the square root of 2 gives me the square root of 4. So I got 9 plus 4 times the square root of 4 is equal to c squared. But the thing is that the square root of 4 is a perfect square. So what I'm going to do is, I know that the square root of 4 comes out to be what? Comes out to be 2. So really what I have is 9 plus 4 times 2 is equal to c squared. And of course, you remember from PEMDAS, please excuse my dear Aunt Sally, you always do parentheses, exponents, and then multiplication first, right? So you're going to multiply these two first, which is going to give you 8. So you have 9 plus 8 is equal to c squared. And of course, 9 plus 8 is 17. That's equal to c squared. We don't want c squared, we want c. So what do? We take the square root of both sides, and c comes out to be 4.12. 4.12. Okay? Let's take a look at another situation here. Again, I have a right triangle, and my right triangle, they give me one leg. I'm missing the other leg, and in this instance, they give me the hypotenuse. So again, I have to use what? I have to use the Pythagorean theorem. Here it is right here. We know that this side here is always going to be what? It's always going to be c, and this, let's just make this a. So I'm going to have a squared, which is 5 squared, plus b, which I don't know, is equal to the hypotenuse, which is 6 times the square root of 9 squared. 5 squared is 25. My b squared comes down. And now I'm going to be squaring my hypotenuse, right? I'm going to be multiplying it times itself, because that's what squaring means. It means you multiply it times itself. So I'm going to be multiplying it by itself here, okay? So my 25 comes down. B squared comes down. Now, 6 times 6 is 36. The square root of 9 times the square root of 9 is the square root of 81. But then I know that, hey, wait a minute, the square 81 is a perfect square. So the square root of 81 comes out to be 9. So my 25 comes down, my b squared comes down, I bring down my 36, and really what I have here is not 36 times the square root of 81, but 36 times 9. So the 25 comes down, the b squared comes down, and 36 times 9 is 324. And of course, I'm trying to solve for b, so now you know what I'm going to do here. I'm going to subtract 25 from both sides. B squared is equal to 299. I don't want b squared, I want b. So I'm just going to take the square root here, and that's going to, the square root of b squared is b. The square root of 299 is 17.29. So the length of that third leg right here is 17.29. Okay? So here are two more questions here that I would like you to try. Try to find the hypotenuse of this figure here, and then try to find the leg of this figure here, and I'll give you guys a few minutes to figure that out. Let's see what we can get. Let's get to work.